this video, you're going to learn why this problem looks harder than it is, but we're going to absolutely crush it in just a few minutes. Now, before I dive right in, let me introduce myself. I'm Dave, and I used to tutor students like you back in college, and I'm actually a software engineer where, because you guys have been so helpful helping me to grow my channel, I made a Number Ninjas math game you can check out for your iPhone and iPad below. Now, going back to this problem, imagine for a second that this was secant squared of x dx. What would the answer be? It's pretty simple. Well, if you don't see it, it would just be tangent of x plus c, right? Because the derivative of tangent of x with respect to x is secant squared of x. However, we have this larger power here, but it's okay because we can actually use a trick where we imagine that secant to the sixth of x is a product of two simple trigonometric terms that are easier to work with. So now we have this secant squared of x on the left, but what do we do with this secant to the fourth of x on the right here? Leave a comment if you see it. Okay, if you didn't catch it, what we want to do now is, if we know the derivative of a tangent of x term gives us this, if we can somehow bring tangent of x into this problem, we can then use a U-substitution, right? Where we will let u equal tangent of x. Now, the way we can do this is I want you to look at the fact that secant to the fourth of x also can be rewritten as secant squared of x all squared. Well, what do you know about secant squared of x with respect to your trigonometric identities? Secant squared of x is the same way as writing tangent squared of x plus 1, which I put here in parentheses, and now this is all squared. This allows us to now use a U-substitution to solve the problem, where I'm going to go ahead and let u equal tangent of x, because now when you take the derivative of both sides, du equals secant squared of x dx, and all of this on the right appears in the integral, right? So that all will become du. Now, the simpler integral that we're going to see is dealing with a polynomial integration problem now, which is super simple compared to what we started with. With u squared plus 1 all squared, I'm going to go ahead and expand the terms. And now you can think of this as a sum of three separate polynomial integrals, right? We know that integrating u to the fourth du gives you 1/5 u to the fifth plus c. I'm going to hold off on the plus c just for a second. And then you get the other terms you see here by integrating them above. And then I like to always show the plus c at the very end of the problem after I plug back in my original x variable, right? Because we know that u equals tangent of x, giving you this answer. So I hope this video made this problem really simple for you to solve. And if you want to absolutely crush your next exam with some more integral problems, check out this next video here.